when we deal with this, I want you to think of this just as working with fractions. Now, I realize that most of you dislike fractions. You don't understand them. But we're going to try and work through some of that so that you can see how these things go. The best way to do these is to simply just work them out and see what you can come up with. Now, first thing I got to do is multiply rational expressions. Now, you do remember that when it comes to fractions, you multiply the numerators together, you multiply the denominators together, correct? Okay. So, if I take a look at what I have here in the numerator, I've got 5ab squared multiplied by 12a squared b squared. Well, what's 5 times 12? So it's 60. I have an a here and an a there, so that's how much? A cubed. Because I have 1a here, 2 over there, a cubed. And b is going to be to what power? 4. Okay. All I did is multiply it together, just like we've done in the past. Denominator, same thing. What is 6 times 3? 18. B squared, and I have a b cubed, so that's going to be b to the 5th power. Now, students always want to know, do I cancel first? Do I multiply, then cancel? To be honest, it doesn't matter, because canceling is a division process. Multiplication and division go hand in hand with each other. So, now we can simplify from this point. So, if I have 4 b's up here, can I get rid of 4 from down here? And so I will just be left with 1b. I have an a down here, and I have 3 a's on top. So will this a cancel out one of the a's up here? And I'll be left with squared. So I end up with a squared. Now I have 60 and I have 18. What divides into both of those? 6. 6 goes into 60 10 times. 6 goes into 18 3 times. So I end up having 10 over 3. That's it. That's the simplification process. Now what we have to do is we have to put in a is going to be 4, b is going to be 5. So for the next step, it's going to be 10 multiplied by parentheses squared. What's a? 4. So I just put 4 over 3 parentheses. What's the b? 5. Yeah. So when I look at this, what's 4 squared? 16, correct? 10 times 16 is 160. On the bottom, 3 times 5. Well, that's going to be 15. Can I simplify? Now, this is where understanding the process and seeing what's going on with your numbers helps. If I look at this, this is that's got a 0, that's a 5. Both of these are divisible by 5, correct? So if I go and take 160 and divide it by 5, that gives me what, 32? 32 over 3. So I can leave it just like that, 32 over 3. Now, if I would have been paying attention up over here, this 5 could cancel with this 10. How many times does 5 go into 10? Twice. 5 goes into 5 once. What's 2 times 16? 32. 3 times 1, 3. I get the exact same answer. There is more than one way to look at it, and a lot of the time it depends upon what you see, what strikes you. Now, could have I even done simplification up in here before I did anything else? Yeah, I could have done it there. Again, it doesn't matter where you do it, just as long as you apply the rules appropriately. So, let's give this one a whirl. Now, I have additions and subtractions going on in here. Part of the reason why I did all the multiplication over here and simplify it at the end is because I don't want you just to jump into it and just start hacking away at things. You have to pay attention to what you're working with. This is all multiplication up in here. Once I get down into here, we've got FOIL going on, distributive properties going on. But that is not how we are going to do this. Now it does say multiply and then identify all of the values of x that make the expression. There is a way of doing this so that it makes life a lot simpler. What we are going to do is simplify each one of those first before we go through and multiply. Okay? So, I'm going to start with the first one up here. I've got 15x minus 3x squared. Well, if I look at this, I should be able to factor out a 3x. So that leaves me then with 5 minus x on the inside. Okay, now just bear with me on this because you'll see the reason why I'm doing this in a little bit. Now, denominator. Down here, I've got x squared minus 9. That's difference of two squares. So that's going to factor out as x minus 3 and x plus 3. Now, up here, I have got x squared minus 8x plus 5. So I know with a plus being back there and a minus here, it's going to be x minus and x minus. So what factors of 15 will get us to an 8? Well, that would be a 3 and a 5, correct? 3 and 5. I know we've been practicing these for a while, but I want you to be able to deal with these things. So, question? X times x is x squared. X times x is x squared. 3x times x is negative 3x squared. 3x times 5 is 15. Distributive property. So, next one. Minus sign, plus sign here. Okay. We know it's got to be an x. We know it's got to be an x. It's got to be a minus and got to be a minus. So, what factors of 25 get us to a negative 10? Negative 5 and negative 5. Now, here's where the fun part comes in. Rather than trying to multiply this entire mess together, I can cancel some stuff. This x minus 5 would cancel with this x minus 5. It's just multiplication. This x minus 3 cancels with this x minus 3. Okay? Same thing on top, same thing on the bottom. We can cancel it out. Now, I'm looking at this one right here. I got x minus 5, and here I got 5 minus x. If I want to, can I adjust this so I can cancel here? And the answer is yes. Rather than having 15x minus 3x squared, I'm going to factor out a negative 3x and watch what happens. Well, if I take a negative out of here, this turns into a minus 5. Negative out of here, that gives me a plus x. If I rewrite this I get negative 3x times x minus 5. So what I want to do here is I am going to erase this, and I'm going to replace it with this. I realize it looks kind of like good old voodoo economics there, but I just did a whole bunch of hocus pocus and it happened. These are things that you see as you go and do these problems. Now, can I cancel again? I can cancel one more time. I can get rid of this x minus 5 with this x minus 5 here. So what's left? The only thing left is negative 3x over x plus 3. Nothing can be canceled here because this is multiplication here. This is addition. Now, there is one more step that they want us to look at here. And that is this idea of make the expression undefined. The only time that an expression is undefined is when we have division by 0. So my question for you is, what can't x be equal to? In other words, what number could I put in here for x that will make this go to 0? Okay. Now I realize that this is a lot of factoring that you're looking at here. Most of the time the factoring is going to be fairly simple. But if you would have tried to multiply all of this stuff together, you wouldn't have gotten anything that could cancel. Because the only time that we can cancel is if we have multiplication. Are you ready for the next example? Now, as I am going through it, if you see something that doesn't look right, make sure that you say something. That way I can catch where it's at. So, here we go. I've got 3 things that are next to each other here that all get multiplied together. I am going to go and do the factoring if I can. Some of these I can't factor, and I'll show you how we leave those so that we don't have to worry about it. So, for the first one, I've got 5x and 10. Is there something that you see that can't be factored out of those two terms? What? 5. So if I pull a 5 out, I am going to be left with x plus 2. Now, I look at the next one. Is there anything there that I can factor out? Well, I look at it, I got a minus in there. Do I have a difference of 2 squares in my question? Well, 9 is a perfect square, x squared works, and 1 is a perfect square. So yes, this gets factored out as a difference of 2 squares. So this will be 3x plus 1, 3x minus 1. We've seen that factoring before. Now, on the last one up there, is there anything there that I can factor out? And the answer is no. You see that, and it's just plain old x plus 1. But this is x plus 1 multiplied by all this stuff. So what we're going to do is put in a set of parentheses as x plus 1 as just another way of writing out multiplications. Now, all of those are getting multiplied together. Now, we have to go through and see if we can cancel anything out of this thing. I got 3x squared plus 2 minus 1. Well, I can guarantee you that it's factorable. Simply because of the examples here, and that's what we want to do, is being able to factor. So, no, it's going to come out like this. That's one's got to be plus, one's got to be minus. I look at this and I see that my factors are 3's and 1's. Well, if I subtract 1 from 3, I get 2, don't I? So what I'm going to do is I am going to put 3 here, 3x there, and I'm going to put an x there, because that'll give me my positive 3x. This has to be a 1, and that has to be a 1. Because positive 1 times negative 1 is going to give me 1. X times negative 1 is negative 1x. 1 times 3x, combine them, 2x. Now I realize that there's a number of you that love doing this stuff in your head. You should be able to see that. For those of you that don't, FOIL it out just to make sure that you've got it. This isn't about trying to get by with the least amount of work as possible. This is trying to figure out how to simplify this. So now, I look at this one. I see I've got x plus 2. Is there anything that I can factor out there? No. So that just goes in parentheses, x plus 2. I look at this one here. Is there anything here I can factor out with 15x and a 5? I can factor out that 5. So I am left with x plus 1. Yes, sir. Shh, quiet. It's 3x. What are you talking about? Yeah, it's 3x plus 1. That's generally what it's got. A lot of stuff there, so make sure you keep it in mind. Now, we get to go through and slice this thing up and get rid of the things on top that match the things on the bottom. I've got a 5 here that matches a 5 there. I got an x plus 2 that matches an x plus 2. I got a 3x plus 1 that matches a 3x plus 1. I got a 3x minus 1 that matches a 3x minus 1. I got an x plus 1 that matches an x plus 1. That simplified all the way down to 1. Okay? Okay? Perfectly legal. Multiplied everything out, it just canceled itself right down to 1. Now, would you have ever thought that that mess would simplify to 1? No. But you have to make sure that you go and factor it all out and then cancel. Ready for another one? Okay. When we're looking at these, we always want to put these in terms of a numerator and denominator. This is how it works best. So if I look at this one, I see I got x plus 4 over x squared minus 4x multiplied by. So what do I do with that other piece there? Well, if you remember correctly, if I want to turn something into a fraction, all I got to do is put it over what? 1. So if I want to turn this into a fraction, I am going to put 2x squared minus 9x plus 4 over 1. Now, I have a numerator to work with. I have a denominator to work with. So, here we go. I look at the first part there. Is there anything that I can cancel? The answer is no. Parentheses, x plus 4. I look here. Does this look like it's going to be factorable? Probably. I'm looking at 2's and 4's, and I got to get to a 9. So there should be something in there that should work. We'll have to look at that. So both of these are negatives. And let's see, the only way to get a 2 is to have a 2 and an x and an x. So, I know how I can do this. I could put a 4 here, and I can put a 1 there. Will that work? Let's check. 2x times x gives me 2x squared. 2x times negative 4 minus 8x. Negative 1 times x, negative 1x. Negative 1 times negative 4 plus 4. Add like terms, 2x squared minus 9x plus 4. Yay, it worked. Okay? Well, sometimes you just got to check it and make sure that it did work. Otherwise, okay. What about on the bottom? Is x squared minus 4 factorable? And the answer is yes. What can I factor out there? Well, I can factor out an x, and I am left with x minus 4. Okay. So, is there anything I can cancel? Here we go. So, I'm going to cancel here and cancel here, because those are the same, right? So now, depending upon how things are going, you could just leave the answer as x plus 4 over 2x minus 1 all over x. It really depends upon what the instructions are. Sometimes they want you to FOIL it out so that you end up having to have 2x squared minus 1 plus 4, so it'd be plus 3x minus 4 all over x. Either way would be acceptable. Kind of depends upon how they're working it out. Just as a side note, this stuff is what college algebra classes in college, they love this stuff. This is basic algebraic manipulation that they beat the living daylights out of you with this stuff. So, ready for another one? Are you beginning to see the shortcuts, the way it works, and what does and doesn't happen? Okay, so I'm going to give you a moment here, and I want you to make sure that you have this written down. All right. If we take a look at things, we've been told that, oh no, you can't divide by a fraction. Well, technically you can divide by fractions. You just break it up into smaller, really small pieces. I mean, if you think about it, if you take something and divide it up into two pieces, you just cut it in half, right? But now if I divide by half, that means my pieces are going to be of size. More smaller pieces. But I want you just to keep this in mind, because this is going to be how we deal with this. Okay? First fraction stays the same. Second fraction gets flipped around. So, multiply by the reciprocal. So, here we go. I want to deal with this one here. We're supposed to go through and take 12x cubed over 5y and divide it by this, but we can't divide by a fraction, so we multiply by its reciprocal. So this goes to multiplication, and we flip it around. What was on the bottom now is on the top. So now I'm going to have 5x cubed y squared all over. What was on the top is now on the bottom, 4x to the 5th. That is how it happens. Alrighty, here we go. Now, the 4. I'm going to cancel because we got all multiplication here. So this 4 would cancel with the 12, and I would get 1 and 3. Do you agree with that? Okay. I'm going to cancel this 5 here with this 5 up there. Does that work? Well, that leaves me with, I'm just going to put this together now. I'll deal with the variables when I have one on top and one on the bottom. So if I look at this, I have 3x to the what? Yep, 6 because I got 3 here and 3 there, y squared. Down below, I just have it 1, but I don't need that. I'm going to put a y and an x to the 5th. Okay? You see where they all came from. Now, last bit of canceling. I have 2 y's up here, I have 1 y down here. So this y disappears, and I only have 1 left here. I have 5 x's down here, 6 x's up here, so 5 of these cancel out with 5 of them up there, and I'm left with 1. So the final answer for this thing looks like this, 3x. Now, we're supposed to evaluate for x is equal to -2 and y is equal to 3. Do I even have any y's left? And the answer would be no. So I am going to take 3, multiply it by -2, -6. That's it. Okay. Did I add what, y, where? Oh, did I forget the y? Yes, I did. I forgot the y. My bad. I forgot the y. Yeah, so that means that this here is going to be 3. And, yep, that was me. So that turns out to be -18. Okay. So, makes sense. Let's try one more. They want us to divide and then identify all values of x that make the expression undefined. So, we start off with x plus 1 over x minus 2. Multiply. Flip it around. Please, while you are working on these things, do not try and do 2 or 3 things at one time. Just flip it around. So I got x squared minus 2x, and then x squared minus 3x. Then, if you need to, factor. So this turns out to be x plus 1 is still there, in parentheses. X minus 2 is still there. So I look up here, what can I factor? Well, I can factor an x out, and I'll be left with x minus 2. Now in the denominator, I see that I can factor out an x as well, so I would be left with x minus 3. So, is there any canceling that I can do? I can cancel off the x here with the x here, the x minus 2 with the x minus 2, and so I am left with x plus 1 and x minus 3. Now again, they want us to identify what value can't x be equal to. What can't x be? What would make the denominator 0? What number can I put in here that would make it go to 0? And that's it. I'll continue with more examples tomorrow, and we'll do some practice problems.